Last couple of videos we have seen how to detect the edges. So in this video, or let's see, listen, we will try to see how we can detect corners and why we need also to detect corners. And finally, I will show you a Python code. So let's see here, what is the corner indeed? So the corner, it's not just like a sharp angle like we see in what we see in real life. In a computer vision, is a corner is a point where an image intensity, you can see, image intensity is changed significantly in at least two directions. You can see, for instance, in this direction and this direction. And here we can see a corner. And why we need to detect the corners? If you see, we needed to detect the objects. We needed to motion tracking. Sometimes you need to detect uh, to track some, let's see, some only some points even, and also alignment. Sometimes you have maybe you have an application that taking an image and sometimes it has a little rotation. So the application will try to align this image. Sorry, and also the 3D reconstruction, which is useful for the pen picking for the robot. Is try to take, for example, picking an object. And let's see here. So now we have three types of image regions. It's the flat region here, which is significantly no significantly change in the intensity in any direction. For the edge, it's only in change the intensity change in one direction, this or this, and for the corner, it has atlas into directions like this and this. So how to calculate the corners, or let's see how to find the corners. In the first step, we have to compute the image gradient in both directions. So if you are not familiar with Sobel algorithm, please refer to the Sobel algorithm, because Sobel algorithm, it has two different filters, one for x direction and one for y direction. And for that, we have to apply and get the gradient in x and y direction. And because we have H region, let's see, for instance, let's assume this is the image, and I will try to select the 3 by 3 image here, and calculating in X and Y direction. And here we have the gradient, and let's see, I have, let's see, taken a small region, which is 3 by 3, and for that, for instance, I have 9 pixels here, and for each pixel, we already calculated the gradient in x and y directions. So let's say we have 18, 9, 9, 18 with this equation here, with this one here. Now, how the has detect the corners after calculating or constructing this matrix here, we have to calculate the determination of m and also the trace. The determination of m, it's this times this minus 9 times 9, and the trace is this 18 plus 18. And for the key value, it's typically chosen between 0.04 and 0.06. So now if the r is positive, well, let's see, greater than a specific threshold, it will be this pixel will be considered as a corner. And by the way, Harris and also Shi algorithm, it's rotation invariant. What does that mean? So it means if you rotate this image here, so you will, for instance, you rotate it with 25 or 45 degrees, you will still detect the corners because it's not changing anyway. But scaling, it might be not able to detect. And the shy, it's the same algorithm, but they try here to taking the minimum eigenvalues. So from this matrix here, they try to calculate find the eigenvalues and eigenvectors. I mean the eigenvalues, and taking the minimum. And if it's greater than the specific threshold, they will see it's a corner. And by the way, if you are, let's see, interested in to see what is the eigenvalue and what is the eigenvectors, I have explained this in a playlist of machine learning and principal component analysis. So this is a comparison. You can see the rotation invariant, both are okay. Computational cost is high and here lower. Indeed, I have, I don't know why it's lower, because calculating the eigenvalue and the eigenvectors, it's taking much time. But I have also seen in different resources, they said this is faster. Let's see. And some applications we have already seen in the beginning. Uh, Sometimes we need, for instance, 3D reconstruction, which is matching the corners in stereo images, and also robot navigation. You have a robot and you need to localize an object to pick these objects. And yeah, so I think this end of this. Let me just show you the Python code. Okay, it's the same example of the as we have select the kernel. Now you can see the kernel is defined in when I open a Python file, for instance, like this. You can see this is the kernel. Now I have chosen this, run this value here. What is that? Choose an okay. Yeah, because they have no image with the same example, with the same name, it will try to detect, it will try to use make synthetic image. And for the synthetic image, we try to convert grayscale, which is already indeed grayscale image. So we can see like, oops, no, it's equal image, just for simplicity. Let's see like this, and you can see now we have the image now here. So we now try to detect the Harris corner using Harris. The block size is 2 by 2. The kernel size is 3. The block size is, after calculating the edge gradient in X and Y for each pixel. Now after that we will see, we'll take 2 by 2, let's see, region, and calculating the Harris corner, if it's there or not. And the dilation, sometimes it's just to make the corner, or let's see, the corner is it's thicker. Sometimes we just need to connect some corners, some dots, let's see, or points. And let's see now, run this, because okay, the image, it has to be indeed color image. So for that we can just copy this. Maybe this would help. Let's see. No, so we can just use it grayscale image to red, blue, green, red, just to make it simple. So now let's run, and now you can see the Harris corner. It's trying to detect these corners. But if now we run the second algorithm, we can see a different result. You can see it's detecting even these lines as the corners. But for with this example, I will see the Harris, but depends also in the example indeed, in the image itself. So that's it for today. And of course, if you have any question, just drop it down in the comment below. I will answer it definitely. And see you next time.